What's up, future engineers? Ako nga pala si Jerome A. Ymas at nandito tayo ngayon upang pag-aralan kung ano nga ba ang ibig sabihin ng Water Resources Engineering. Alam nyo ba na ang mundo ay tinaguriang blue planet dahil nagtataglay ito ng halos 3/4 o 71% ng mundo ay puro tubig, which is equivalent to roughly 326 million cubic miles. Unfortunately, maliit na porsyento lamang ito ang nagagamit ng tao na may katumbas na 0.3%. Kaya isa itong malaking hamon sa field of Water Resources Engineering. Kaya nandito tayo upang pag-usapan kung ano nga ba ang Water Resources Engineering.
Ito ay isang espesyal na uri ng civil engineering kung saan nakapaloob ang pagdisenyo ng mga sistema at mga equipment na makakatulong sa pag-manage ng human water resources. Ang ilan sa mga bahagi nito na kinasasangkutan ng mga water resources engineers ay water treatment facilities, underground wells at natural springs. Nakapokus rin ang mga ito sa water supply, irrigation at water disposal. Sa karagdagan, isa itong pag-aaral sa management of equipment, facilities, and techniques na ginagamit sa pamamahala at pagpreserba sa water sources kung saan tinatalakay dito ang mga methods of controlling water para maiwasan ang water-related damages and catastrophes.
Ngayon, alam na natin ang tungkol sa Water Resources Engineering. Ngayon naman, ating alamin kung ano nga ba ang gampanin ng isang Water Resources Engineer.
What's up guys? So nito naman tayo ngayon para sa ating Engineering 101 with me, James A. and Sedutan, ang inyong lecturer para sa Water Resources Engineering. So kanina nga na-discuss ni Mr. Ymas yung tungkol sa Water Resources Engineering. So ngayon naman, ang topic natin is about the role of a Water Resources Engineer. And first, let's all describe what is a Water Resource Engineer.
A water resource engineer is a professional who took a subdiscipline of civil engineering, which is the water resources engineering, and they are the ones who deal with the provision of clean water, disposal of wastewater and sewage, and the prevention of flood damage. Kung structural engineer is for designing and constructing the structures, transportation engineer for roadworks and traffic, geotechnical for rocks and soil of the site, environmental engineer, well, for the environment. Ang water resources engineer naman is for designing and constructing hydraulic structures such as dams. No, not that dam. This dam. Yan. And we also have weirs. Oh, di nyo alam yan, no? Ako din pero according to Google, a weir is a barrier across the width of a river that alters the flow characteristics of water and usually results in a change in the height of the river level. In other words, isa yang dam-like structure, but instead of functioning as a reservoir, its main function is just to control the stream or the flow of water, and on some instances, to increase the height of the water level. Ayan, may bago na naman kayong nalaman. Now, Water Resources Engineering is a subdiscipline of civil engineering. So, it will take you 5 years before ka maging Water Resources Engineer. Pero di natin alam, baka abutin tayo dito ng lifetime. So, okay, that's the Water Resources Engineer.
Now, alam na natin kung sino ang tinatawag natin Water Resource Engineer. So ngayon naman, alamin natin kung ano ang mga gampanin o tungkulin nila sa ating industriya. So katulad ng ibang discipline ng engineering, bigyan natin ito ng tatlong roles. First is the design. Second is the construction. And third is for maintenance and repair.
So first, we have the design. And under that was the sewer improvement plans. So ang water resources engineer is the responsible sa kung papaano yung magiging route ng pipes underground, including yung mga drainage systems, yung kanal, yung pumping stations, hanggang sa makarating yan sa treatment plants or sa disposal areas. So it's their job para maisaayos yung linya ng sewer, lalong-lalo na sa mga populated areas tulad dito sa Manila. Next, They were also the responsible for flood defense programs, including yung mga dams, yung mga river defenses like yung kanina, yung weirs. We also have the levees or tinatawag din nating flood bank, diversion canals, and coastal defenses such as the seawalls. Ayan, and a lot more. So sila yung gumagawa ng mga structures and systems na yan to prevent the flooding. Third, we have the provision of clean water. So ang mga water resources engineer, from their name itself, ay ang nangangasiwa kung papaano makakarating ang malinis na tubig sa mga lugar-lugar. Sila yung nag-iisip kung papaano patuloy na dadalo yung tubig sa mga matataas at mahirap abutin na area. Kaya sa tuwing maghuhugas ka ng pinggan, isipin mo na may mga engineer na nagpakahirap para lang madala sa mga tao ang malinis na tubig. Ayan, so aside from design, another role of a water resource engineer is the construction. So first, liaising with various agencies and individuals, including local authorities, government agencies, clients, contractors, residents, suppliers, technical experts, and consultants. So upon construction, it is the obligation of a water resource engineer na makipag-ugnayan sa iba't ibang ahensya and other people regarding sa project. Next, preparing tender documents for construction. Siyempre, upon construction, responsibility ni water resources engineer na ayusin yung mga papeles about sa project tulad ng mga permits and other necessary documents. Third, keeping track of the progress of projects from beginning to end. Since ikaw nga ang engineer, ikaw ang nakakaalam ng plano sa DAP, so dapat lang nabantayan mo yung ongoing project para in case na may mali or may hindi nasunod dun sa plano mo, is makorek agad and maiwasan yung mga errors. Dahil nga napaka-crucial ng mga projects na related sa water, like yung mga dams, magkataon lang na may mali sa structure, maaaring magdulot yun ng malaking pinsala. So next, controlling budgets at the project level. Well, ito, automatic na ito kasi ayaw naman siguro natin na magkaroon ng problema pagdating sa budget. And once na you become an engineer, alam dapat natin yung mga estimation ng prices para iwas tayo sa errors. Next, ensuring that work is completed to a deadline. Ito ang napakahalaga since we were hired to accomplish or finish the project in a specific time kasi pwedeng maka-apekto to sa masses or even sa kumpanya. Like kunwari, today is the deadline na dapat nung pag-i-install ng bagong water pipe, di natapos. So, apektado na agad yung mga consumers noon dahil sa water interruption. Next, managing staff, including other engineers, technicians, and site workers. So, ito, pakikipag-interact natin with other people in this site. So, it's our obligation to guide other people that were helping us to finish the project. And the last role of a water resources engineer is the repair and maintenance. And first, keeping up to date with environmental matters and being aware of policy and developments. It means na dapat aware tayo sa mga factors na maaaring makaapekto dun sa project. Like for example, may batas pala na ipinasa na bawal na yung ganito. Tapos meron sa project mo. So pwede mo na agad magawa ng paraan yon. Or di kaya naman, kunwari ay tumaas yung sea level dahil sa climate change. And yung seawalls na nilagay nyo is underneath the water na. So you can improve it na. And next, identifying possible errors. So it's your duty as an engineer to inspect your projects if something was not right. Like assessing if meron bang mga risk bago i-occupy yung project. And it is your job to do maintenance on your projects. And that's the role of a water resources engineer.
Muli, I am your lecturer, James A. and Sedutan para sa ating Engineering 101. And ang next topic is about the field of interest ng water resources engineering. So take away, Mr. Arevalo.
Hello mga kaignog! So ang third topic natin ngayon ay field of interest in water resources engineering. So ano pa hinihintay natin? Let's start! So nagbabalik na naman ako ngayon no, mga kaignog. So bago tayo magsimula, ano nga ba ang mga field of interest in water resources engineering? Una, irrigation engineering. Ikalawa, coastal and river engineering. Ikatlo, drainage design. Ikaapat, flood control. Ikalima, groundwater hydrology or geohydrology. And last but not the least, water resources management. First, irrigation engineering. It studies the irrigation and agriculture in depth. Irrigation engineering is a field of engineering which will discuss the uses of irrigation in crop production and how new technologies can be used and applied for irrigational practice. So basically, the irrigation engineering focuses on how the water will help the goods become productive. But the primary responsibility of an irrigation engineering is not only related to the application of water. Instead, it deals with various other aspects. First, it deals with the designing and planning of the irrigation systems. Second, it deals with the problems that may arise in the watershed or the agricultural fields. Third, the study of irrigation engineering deals with the rivers and the hydrology. Fourth, it is study of water, soil, and crop relationship. Fifth, it deals with the design and structure of dams, canals, other hydraulic and irrigation structures. The main job of the irrigation engineer is to find the efficient cost and effective ways of an irrigation which costs less and yield better results for more productive goods. Second, coastal and river engineering. The complexity of river and coastal engineering projects calls for an integrated approach. All aspects must be covered, from construction engineering and design to the socio-economic impact. The coastal and river engineering is involved in river engineering projects and studies for river cleaning works, river bank protection, river widening, and deepening, dredging projects for navigational purposes, ship locks, river regulation works, hydropower, river waterfront development, and rehabilitation of natural floodplains and river habitats. The coastal and river engineering studies and projects include structural and non-structural solutions or nature-driven design, coastal protection, offshore land reclamation, beach nourishment by dredging, closure of estuaries or lagoons, breakwaters, ports, access channels, and coastal waterfront development. Third, drainage design. Drainage systems comprise a complicated mix of components, from straight inlets to pipes, and from streams and open channels to ponds and control structures that are designed to attenuate flow or prevent pollution. Fourth, flood control. Civil engineers play a vital role in protecting communities from the impacts of flooding, which can happen at the coast caused by the sea, or the inland caused by rivers, waterways, or excesses of water in the local drainage network, or from surface water or groundwater. Flood control measures on many large rivers includes levees contain high discharge. When floods do occur, the levees constrain the water, making it move faster and deeper in the main channel, instead of spreading it out across the floodplain and flowing with a lower average velocity, as it would naturally. Drainage networks are also important in preventing flooding, especially in towns and cities, by effectively collecting and removing stormwater and other surface runoff. Fifth, groundwater hydrology or hydrogeology. Hydro means water and geology means the study of the earth. It is this area of geology that deals with the distribution and movement of groundwater in the soil and rocks of the earth's crust, or commonly in aquifers. Groundwater engineering, another name for hydrogeology, is a branch of engineering which is concerned with the groundwater movement and design of wells, pumps, and drains. The main concerns in groundwater engineering includes groundwater contamination, conservation of supplies, and water quality. Wells are constructed for use in developing nations as well as for use in the developed nations in places which are not connected to a city water system. Wells must be designed and maintained to uphold the integrity of the aquifer. and to prevent contaminants from reaching the groundwater. Controversy arises in the use of groundwater when its usage impacts surface water systems or when human activity threatens the integrity of the local aquifer system. 6. Water resources management. Water resource management is the activity of planning, developing, distributing, and managing the optimum use of water resources. It is an aspect of water cycle management. Water is essential for our survival. The field of water resources management will have to continue to adapt to the current and future issues facing the allocation of water. Ideally, water resource management, engineering, and planning regarding to all the competing demands for water and seeks to allocate water on an equitable basis to satisfy all uses and demands. One of the biggest concerns for our water-based resources in the future is the sustainability of the current and future water resource allocation. As water becomes more scarce, the importance of how it is managed grows vastly. Finding a balance between what is needed by the humans and what is needed in the environment is an important step in the sustainability of water resources. Civil engineering on water resources focuses on water resources management to seek and harness the benefits of water by ensuring there is sufficient water to adequate quality for drinking water and sanitation services, food production, energy generation, inland water transport, and water-based recreational, as well as sustaining healthy water-dependent ecosystem.
So yun nga mga kaignog, no? So doon nagtatapos ang field of interest in water sources engineering. Ang next naman ay di-discuss ng next vlogger ay ang core subjects ng water sources engineering. So yun nga guys, no? Babush!
Good morning! So today I'm gonna discuss to you the core subjects under water resources engineering. By the way, what are the core subjects under water resources engineering? Roll VAR.
Core subjects of water resources engineering are the following. First is engineering mathematics. Engineering mathematics is a branch of applied mathematics concerning mathematical methods and techniques that are typically used in engineering and industry. Ang mga example natin dito is the usage of mathematics equation to study the chemistry of materials. In physics, mathematics in engineering is used based on application around algebra, calculus, and geometry. Engineering mathematics is also used to get the cost estimation of the project. Also, the basic principles of accounts and statistics. Engineering mechanics. Engineering mechanics is an application of mechanics to solve problems involving engineering elements. Also, it deals with the laws and principles of mechanics in their application with engineering problems. Ang goal ng engineering mechanics ay para ma-expose ang mga estudyante sa mga problema patungkol sa mechanics na maaaring ma-apply sa real-world scenarios. Third is engineering geology. Engineering geology is a scientific discipline concerned with the application of geological knowledge to engineering problems. Example under engineering geology are design for reservoir and location, determination of slope stability for construction purposes, determination of earthquake, flood, or subsidence danger in areas considered for roads, pipelines, or other engineering works. Fourth, fluid mechanics. Fluid mechanics is a broad engineering field that studies the fundamental behavior of fluids, substances known to statically deform under applied shear stresses. Sa fluid mechanics, nade-develop ang basic foundation and mechanics of fluids. Also, ina-assess nito ang mga student para magkaroon ng knowledge sa fluid properties, application of flow measurement techniques, determination of turbo machinery, characteristics, and application of conservation laws. In application, dito pumapasok ang design of conveyance structure, design ng dams, water supply system, wastewater system, irrigation systems, at design of piping systems. Fifth, hydraulics engineering. Hydraulics engineering is an application of fluid mechanics to water flowing in an isolated environment, such as pipe and pump, or in an open channel like river, lake, and ocean. In application, hydraulics engineering is used to design hydraulic structures such as sewage conduits, dams, and breakwaters. Management of waterways such as erosion and flood protection, and environmental management such as the prediction of the mixing and transport of pollutants in surface water. Last but not the least, hydrology. Hydrology is the science that encompasses the study of water on the Earth's surface and beneath the surface of the Earth, the occurrence and movement of water, the physical and chemical properties of water, and its relationship with the living and material components of the environment. In short, hydrology is the study of water.
So that's the end of my discussion about the core subjects of water resources engineering. For more information about water resources engineering, please watch the report of Proilyn Ducusin about the significance of water resources engineering.
Ngayon naman, samahan niyo akong alamin ang importance of water resources engineering. Tara!
Ano nga ba ang importance ng water resources engineering? First of all, water resource engineer studies and give information about the sustainable use of resources, first by conserving water, building dams, and conveying water to users. They are also dealing with the provision of water for human use, and they develop techniques for the prevention of destruction from floods. So, it is all about the usage and control of water. It makes our irrigation better, sewage for storms, wastewater, and river systems. They are also designing systems na nakakatulong para mag-match ang ating water supply with our water demands. So, to further explain, there are few problems na babanggitin ko na maaari nating maranasan sa future or nararanasan na natin ngayon concerning our water resources. First, according to United Nations Environment Program, in the year of 2050, 2 billion people will suffer water stress. And in the year of 2025, 2 of 3 person will have water stress. And 1.8 billion will experience water scarcity. So when we say water stress, ang ibig lang itong sabihin, mas malaki yung pangangailangan natin sa tubig kaysa sa available water na pwede nating magamit. So, marami din tayong nararanasan ngayon na problema about sa ating water resources. First, lack of sanitation, and then lack of safe water, and the suffering of children. What does it mean? All of these indicates our problems, or it is a threat for our health. It causes transmission of different diseases, and it may also cause death. Another thing is the typhoon impact. Actually, not just typhoon. There are many disasters that causes destruction sa ating mga structures and causes ng pagkasira katulad na lamang sa mga dams that can cause floods and can cause contamination in water or water pollution. All of these just prove that water resource is limited and we need to manage it. And without water resource engineering, it is impossible for us to avoid those mentioned problems.
So, those are the importance of water resources engineering. Hope you learned something from me. Thanks!